time has passed 9 o'clock, and we are ready to begin. And I would like to say good morning and welcome everybody. Thank you for joining today's online session. My name is Morten. I hope the picture and the sound is good where you all are at right now. In the daytime, I'm a project manager in the Lean Construction Denmark, and over the past 4 or 5 years, it's my clear impression that the use of TAKT planning, TAKT control in the Danish construction industry has been increased a lot, actually. And I think that makes today's topic even more relevant. And I'm very pleased that you will join us today, Janos, and thank you for that. And share your knowledge and experience on this topic. I have a few practical notes before we begin. As you might have guessed, the presentation will be held in English, and today's meeting is recorded. And we also expect to finish at 10 o'clock the latest. Before I hand over the screen to Janos, I would like to briefly highlight 2 of our upcoming events. The first one here on May 17 is very relevant for today's topic as well. It's titled TAKT and Location-Based Planning in Practice, and we have presentation and discussion on how both methods have some challenges and of course potential in the Danish construction sector. Second, I would like to mention our annual conference taking place in August 26 in Copenhagen. Most of the program is already in place, and we are looking very much forward to a strong lineup. And the conference will focus on lean, renovation, and transformation, increasingly important topic in the construction industry. And we hope to see many of you there. And now back to today's topic. TAKT planning, TAKT control, and it's a great pleasure to have you with us here today, Janos. And I know you've been working with this for more than a decade, in mainly the construction department in the BMW group. And to the participants, I think you're all welcome to post your question and comments in the chat, and we have 10-15 minutes, I think, in the end. That's the plan to have a discussion and question for Janos. So once again, thank you very much for joining us, Janos, and the floor and the screen is yours.
Thank you, Morten. First, before I start presenting, because I think the most important part is being together as people, as humans. And so I just want to clarify, it's not just giving you a lesson or something. It's about telling about what we developed and we decided, or also we did in the last years. And there is always up and downs for this. So if you have questions, if you want to stay for something, even critical things like what you can't understand or what is for you not really matchable, raise it. Yeah, there is no there's no ideology or behind that. There is nothing, let's say, to keep it in a kind of sector or try to advertise things. So of course, I'm also with TAKTing. I'm one of the founders of TAKTing. TAKTing is a software company for production systems in construction. That's what it is. I will tell you why we do this, and it's not for money. For first, it's not because we want to get just rich or make just a software startup. We are construction guys from the start on. So I did my own career starting as a normal bachelor. I did in a construction company of my grandfather. I did my first experience when I was 12. So it started just getting a small excavator and saying, go for it, dig the hole, and it's getting amazed me, and I really love this kind of industry. So it's not that I'm from, let's say, production and I just tell the others how to do production. That's not the aim. So it's a full open discussion and it's never ending. So production is not ending. So what the aim of that presentation or also this workshop is how to transfer the knowledge from production to construction. That's the first aim what I have with you guys. So don't go too deep into kind of what you maybe heard from this is TAKT or something. Please try to listen what we really talk about, because preciseness is something what technical people needs. We need preciseness. And not, yeah, I heard that this is this. No, please read again. TAKT is not TAKT time. TAKT time is one part of TAKT, but if you just say it's a rhythm, you totally misunderstand what TAKT is about. It's the same thing about a car is a tire. No, it has tires. It needs tires badly. Without tires, it's not a car. But to say a car is just a tire, then everything what has a tire is also a car, and that's not comparable. So try to really get into the technical things, because it's a technical discussion in the moment. I'm an engineer. I have a PhD in TAKT construction and production and nothing else. It's also not a cultural thing. What we do is technical systems. What you do with your people, how you teach them, how you train them, how you learn with them, how you integrate them. If you do feedback session, if you do last planner, if you do pull, I don't mind. It's not that what we are looking for that in that presentation. We do these things as well in our style, but what we are limiting in this case is just we look for production laws we can use to make us better and quicker and more efficient. And as you like to do it in the lean world, that's up to you. So that's also why sometimes I get these, oh, last planner system, TAKT planning. Oh, they're reviling. They're making some. They discussing with it. I'm talking to Glenn Ballard, for example, or Iris Tomerline all the time. We are friends. So we met in the IGLC groups. We have a now more than 12 years of relationship between this. And Glenn was like, why should this be a? He never heard that, and I discussed it with him. It's like, there is no rivalry in that. There is nothing in there. So please try to make it into the technical things, and afterwards we can of course discuss any kind of aim or something you have in there. So let me share shortly. I brought a small presentation. Now I talked to Morten, but now it's getting a bit bigger. So we try to get through it. I will just shortly scratch it, because I also want to show you in the software why we do things and not how good the software is. Wait. Okay. Can you see it?
Yes, but it looked like it's not the presentation mode.
Okay, I see. Wait, give me a chance to. Now.
Perfect. Yes.
Good. So I wrote down the foundation for technology revolution in construction, and that's exactly what it should be. TAKT is not the philosophy of everything. TAKT is like using math in statics. It's the base for it. TAKT is not giving you exactly the answers for all the systems you are creating in there. But if you're not using TAKT, you're missing one of the big technology things for creating your production or construction systems. And you can use it as you like. It's just a technical thing, a technology. And that's what I want to show you. So the first question what I have to you is, how many production lines are a normal auto manufacturing plant has? So you can type it in the chat. You can just guess as you like. Someone? 1, 2, 3, 4, 5. So if you have one car you build there with different kind of variances, it's one assembly line. But in total, it is between 20 to 60 production lines just to assemble that car. Each production line is a group of production flows that belongs together while it is shaping one product or a pre-product for that car. And next to this production facility, there is huge amount of sub-construction production lines from retailers, or let's say two tiers, second tier production engineers, like brakes, tires, and all the things what you get there. So it's a huge system, and each of these lines is following the rule of TAKT. Different TAKT times, different lot sizes, different products, different modules, different technologies, different robots, everything is different. But they have one in common. Everything has a pace in it to control that production line in itself. We are not looking for controlling the whole system, because each system takes care of the next connection to the next system that takes care of the whole system connections then. So we don't try to control it at the start, the full, we try to control the production line. And this is what we have to create. The production line is in the end the ultimate effective unit for flow. Good. When you go for normal, it doesn't matter which kind of industry you're going. You have Taylorism at the start, where you see that separated work makes you quicker and also not really human-based, but it gives you a huge amount of push in productivity. And it's not about judging it. It's about, that's history. That's part of technology changing the world. And it doesn't have to be good. It has to be at first efficient, and then we make it good. Culture is following this technology revolution there. It was done by steam and water powered mechanical manufacturers. Like, they first used these technologies to run big and heavy machines, like for all the clothes and all the things down. So the second revolution was, the most thing was about TAKT planning, and not TAKT planning, but the production line as it is, and these flow productions into electronic systems. So we have the possibility to do by hydraulic, create a constant flow and use the TAKT system for structuring it. The third revolution was this, let's say, IT connected way of doing things. So we have the possibility to bring in pull and to really use sensors for make quality checks in between. So this is also a technology step backwards, and it always based on the scalability of TAKT, that you start by pulling in lean. To do both together, it's perfect, but to do lean before TAKT is also missing something, because you miss the efficiency of already static and dynamic system. And then in the future, we will look for algorithmic systems, so algorithmic flow systems with new technologies. And in the moment, I try to build these things. And you can see also on the side, there is production systems, production platforms. This is just my personal understanding of how these things work. Good. What is TAKT? Shortly, in one sentence, it's music. And if somebody wants to tell me you need poor or stupid worker just to do TAKT, then go for music. It is artists. Great artists, genius, playing together, because they can't play together that amount of massive music. And this music is structured in 3 dimensions. It's first the TAKT time. The TAKT time is just making the beats first and the last one of a TAKT. The second is the TAKT value. It tells you how you play things. It's if you play it adagio or allegro or forte. So that makes a huge difference of how you play the notes, because it makes you sad, it makes you happy, it makes you, let's say, frustrated. There is different kind of ways of how you can play a note. And then you have the TAKT process, the notes by itself, where you have, in which kind of highness you have to talk to play these kind of, and it doesn't matter which kind of instrument you have there. Everyone has the same notes. Not the same notes. Everyone has his own notes, and the same amount of value, but your processes are changing and the TAKT time stays. That's the way how you get into rhythm. This is the way how you get in a huge audience with a lot of people into rhythm. There is a reason why jazz is just working with 3 people normally, because you don't have notes, you don't have TAKT in this. You go by vibe, and that's totally okay. 3 people, 4 people, they look at each other all the time. They swinging in. So, but if you have bigger groups, you need a technical system to consolidate that, to structure that. So TAKT is something between 3 things. It's process and work, it's time and cycle, and it is value and products. And if you have one of these things not, it's not TAKT. That's the only thing. You need three of these trinity, you need these. And then you're structuring a system into construction. And that's what I want to show you. You have normally production lines where the production line is normally running the product in the production line. In construction, it's the opposite. We are running the production line through the product. So it's like the workers running through the car and building the things inside of the car, because we can't move the building. We have to move our people. So it's an upside down production line. So that's the reason why we have different kind of informations. We have at first trains. Trains are our production line. So a train is not one area. It's multiple areas in products. The products are always on that side here. This is one product, this is one product, this is one product. We call them TAKT areas or floors or what else you want to do. Then you have work package or wagons. This is a station in a normal production line. And in this station, you have multiple works to do from different people. And then you have the train in full, like I can show you. This is one construction line. And you have multiple construction lines next to each other. They build in the end the building. So we have maybe a shell structure production line. We have maybe an earthworks or foundations production line. We have maybe a facade and a roof production line, or maybe one together. Then we have an interior production line for floors. And then we have an interior production line for the offices. And then we have an interior production line for toilets. So it's not that we build everything in one production line. It doesn't make sense. That's the same with a normal automotive plant. It doesn't make sense to build the full car in one production line. It's totally not the way we do this. Then we have a construction sequence, yeah? What a lot of people call train in the moment. The train is for us, the full train is this here. We call this a construction sequence. And then we have work packages. Wagons or train cars, as it say in America. Yeah. So wagons, this is the box where every work has to fit in, even though you don't have it in or not. The box, if you don't keep it there, you change the things as you like, you expand things, you break over the normal TAKT. You can just feel and hear the TAKT if you have the wagon. If you lose the wagon, you lose full orientation in a production system. You have to have always these kind of, and the box shows you one area, one time, and one possible slot for work. So of course it could be more works in that wagon. So you have multiple work packages in the wagon. And these work packages is one part here, as you can see here. This one part here is, in the end, we call it the production unit, because everything in this work package is connected data-wise. So there is no other thing. So it's the full system, it's a grid. And there is just work packages, they content the work and all the other data. There's no other data in there. So what is the content of a work package? It's you can name what you want. Everything what we do is in that production unit. It's our production unit. In car manufacturing, the car is the production unit because this is what flows. The car is the ultimative production unit. For us, the work package is the ultimative production unit. What we used to do there, it's like we are doing the planning stuff there. We're doing quality checks there. We are doing work steps in there. We're doing logistic in there. We're doing even robot steps and sensorings. All data is exactly where it is positioned in the work package. If the work package moves, everything moves with him. If the work package has a different status, everything else is in relation to that status in that work package. So there's nothing bigger than a work package to change. And there's nothing more to add than in a work package. So we have a lot of informations in that work package contained and movable, and it fits to each other wagon in that production line. If you put it out of the production line, of course, you have to reshape it for the next production line. So when we have then a train system, we are looking for a flow of the product that is horizontal. So we can see each of the tagged areas, which kind of stage they have in time. We have a flow of trades, so we can of course see the trades flow in there everywhere if we want, because we see this flow of trades in the, let's say, diagonal, and we see the flow of logistics and the flow of workers and the flow of quality checks always in a tag time. So by these three different kind of flow perspectives, I have a full matrix where I can see the different flows being in harmony or being in disharmony. And in the end, humans are not a mathematical system. They need visuals to understand if there is balance in there, or if they see there is a glitch in there, or there is a disharmony, or a break, or a gap, or maybe something missing, and they can't explain it really. So that's also the reason for the colors. Colors normally is not for the work package the same way, it's for the trades. The trades is the colors, and the work packages in there with the pictograms are the different kind of work for that trade, with different kind of manpower. Each work package has their own manpower because they have to sustain their work continuously. So just for data, when we look for the future of construction, we need data. But what we mostly need is structured data. And everything what is in a work package is already structured by time, by area location, and already by the other work content, like data points in the work packages. So just see what a work package contains in the moment, like to 50 to 500 data points in the moment. But we are scaling that more and more in that one work package up to 100,000 work packages in there, 100,000 data points. When we have historical data each day, we change things, we adapt things. This gives you more and more data, where also machine learning systems can work amazingly good in there. So as more data you have, as more evidence you get there. So there is in the future up to 2 million to 20 million data points per schedule, what we are working on. And each of these data points is giving us a full picture of possible scenarios and structures in the future. So we are sourcing, of course, these data by creating production system and not human-made systems there in fully. So this is how it could look then in the end as a production line system. Of course, you still have bar things in there where you have backlogs, things they are not running in production lines. Normally, we say this in these construction lines, we have around 10 to 20% of the full production for the full construction system has not integrated into any kind of trains or production lines. What I showed above is just the manpower, and you just see work packages underneath and trains and the harmony and the flow, but you can see that the manpower increase tremendously when you have the second train coming in there. The first train is let's say a structure train, and the second train is a fit-out train. You can already see how they overlap each other. You can see which area is focused on which area, because I cut it down, but you see the relation to it. They don't have to be the same areas. Don't get this wrong. They don't have to be the same size of the area. We don't look for repetitive areas. We look for repetitive content of work. So it could be that the first area in that train is a small area and the second area is a big area, because there's less work content for that production line in there. So it is not about the balance of TAKT areas. It's about the balance of the production content, so the work content. So we are TAKTing processes and not areas. That's a very important thing. Is in car manufacturing, you try to TAKT the cars. In construction, because we are flowing the work package, we are TAKTing the work. So we are TAKTing the processes. Good. Just the scalability of work packages. What work packages can do, they have different status. So they have ready, started, done, checked, closed, stopped. And of course, you do different kind of things. You check design steps, you check logistic steps when you start the work. Then when you did all the work steps, then you're done with your work. When you did all the quality steps, then you're done with the check of the work package. Then if you have all the defect steps in there and all the snagging is done, then you close the work package. So also you can pay for this, like you can pay by each work package in different kind of context if you have an escalation way or a trust mode. So all the payment, and we have costs behind work packages. So I just want to show you that everything also in the process by each work package, you can have in the end, in overall 5,000 work package, you can have 5,000 bills by each work package. You can get a different tender, like a micro tendering. And of the other side, you can have a very, very small and very, very precise payment. Just for that work, what he really did good, he gets a payment directly. For the other works, he has to wait for that. And that's fair. It's reactive. It's responsive. It's transparent. It's clear. And in the moment, I don't know how you do it in Denmark. I heard a lot of good things about Danish construction, but in Germany, we do it bulk-wise. So we just say, okay, 100,000 this month, 120,000 this month, approximately the same, then 200,000 in the next month, 220,000 in the next month. And if you have any kind of movements, you just move the things somehow. We call it with a thick thumb. But there's no evidence on this. There's no mathematics behind what shows what you really moved in money. Because the money could be a total different game than just the work package, what you see. Because the next train is, let's say, triple the time of the money what you had in the first train. And you just moved the second train. So all these data things, you can just see if you have the content in there and you move the things with it. So the automatic system, this is also why a lot of people in TAKT systems, if people come to them and say, oh, what is the problem if you change and you don't have a critical path? I don't need a critical path. I see all my flows in my train. I have my production already there and it's organized. And if I move my train, I move my train. If I move in my train, I know what I do because it's not complex. So a train is a production line that is easy to overwatch. So we have 3 levels. So the first is the macro level where we mostly just work in wagons to try to let's say, calculate the train system, how quick they have to be, the speed of trains. Then the second is I try to manage inside of the train the balancing between the trades and the different kind of harmonization. There I also look for the trade flow. But at first I'm designing the production lines above in a mathematical grid. And then last, I executing the things directly in the work packages, even though on a physical board, doesn't matter, but we're still having then the responsiveness into the norm level backwards. So these 3 levels of, let's say, work content shows you directly if you go deeper, if you be more precise, if you have more content to really work in, if you go Gemba, if you do it in the production, then you have more work to go for. And that's what the system is telling you. So you have different kind of TAKTs. Of course, you have a buffer TAKT or also an empty TAKT. Yeah? You have a work TAKT in there. You can change that. You can move a work package into that buffer TAKT if you like. But of course, you can keep them also together. But everything in that train is giving you a dependency on each other. And you can see that directly and discuss this always in a train with your certain team. If you have another train, you discuss this with another team, of course. So you don't discuss the full picture for everyone with everyone. It's about doing the production for the people that really need it, or discuss the things in preciseness, what they really need. And also the tracking of this. So if you do the first work package something wrong, or you had something, let's say some wrong estimations, you can change it directly into the next work package. So you're evolving the system during your working. So it's also a feedback loop. If you have the first TAKT area, second TAKT area in there, you can see if they match the goals or not. So you get more confident. After 3 to 4 TAKT times, you could be really confident that they normally, if nothing is wrong, you can do things. Good. So that's the full system as we are looking for, just in a very slow, easy understanding. They're in the production line. You have multiple possibilities to be quicker. The the major thing is I never saw other system is quicker than that. I can pull the trigger so hard on that system that I can reduce actual in normal construction projects up to 50% of time without changing the full system. When I go for logistics system and trades system, breaking this up, and we even design the logistics system and the trade system in a different kind of way, then I can go up to 70% of time reduction. It's mathematical numbers. It's not that I guess this. It's that what is possible. As you can see on the right side, the calculation of one area here and 50 processes in the end, -1 multiplied with 1 week is 50 weeks. Then we have a 50% parallelization. That means normally 25 weeks. When we chop this down to 5 areas and group the 50 processes into 10 wagons, we are shaping the full train up to 14 weeks. If we chop now each of the areas, let's assume this is 5,000 square meters. So each of that area is 1,000 square meters. If I chop now each of the areas down to 500 square meters, so I have 10 areas by 500, I keep the 10 trades, 10 wagons, and I do now the same amount of work content in there, because 500 square meters normally need half week and 1,000 square meters need 1 week. I get down to 8.5 weeks. If I chop now to 250 square meters per TAKT areas, I'm gaining 20 TAKT areas here. That means in the same math with a quarter week, we're getting down to 7.25. So there is a limit of these things, but I know how to manipulate again to make the same calculation again. So I can reduce the time brutally in projects if I want. That's not the target. But the consequences of this is normal schedules and TAKT schedules, you have normally 20 to 30% already buffers in the back when you go for TAKT planning. If I want to manipulate the system strongly, heavily, I can go for 50. We did projects with more than 500 million. They reduced about 8 months of 16, 17, 20 months of construction. So it's massive, it's brutal, it's also scary if you don't know what you do there, because you speed up the train. It's getting very quick with the things. So you do the things not per week, you do it per day, and then you do it per half a day, then you do it per hour maybe. And that's brutal. Even though your system, the work is not changing, but the movement of the people is changing so fast, and they have to recover for that. And your logistical system has to sustain that. And your information system and your check system and your quality system and everything has to cope with this. And that's the biggest problem. So what a lot of people underestimate is if they speed up the trains, even though they don't raise the people. It's not about raising the people. It's about moving the people and let the gaps between the people being more shorter or closer. They be narrowed to each other. I want to give these examples shortly then at the end. So you have different kind of speeds in a production system. So you have we call it a 1 day TAKT time. So this train speed is then 1 TAKT time per day. Then you have maybe a week TAKT time with 5 days. That means it's 0.2 TAKT times per day. So that is our speed unit. Speed unit means as higher it is, more dramatic it is for the construction site, because the system is more tangent. Then you have a half week TAKT time. This is 0.5 TAKT times per day. And for interior, that's a normal setup for us, for example. Yeah, what we do. So in the end, you can have, of course, you can have also a 2-hour TAKT time. You have an hour TAKT time. That means 8 TAKT times per day. Just to imagine what it means coming from 1 week, 0.2 to 8. How much the speed is more, just to get for this number from 0.2 to 8. That's the amplitude we have there. And if the people are not aware of this, this could totally also crush their construction site. Don't get this wrong. So it's a technology thing. If you speed up too fast with a car and you don't know how to drive and you totally misunderstand the circumstances, wet street or what else, and in the end you said it's a shitty car, that's not the way to go for. You're the driver. Good. So just a short glance, that's what we do. Work package, everything is work package related. No problem is bigger than a work package. Nothing is more complex than a work package. Everyone can clarify content, yeah, of a work package. Data is always referred to a work package. New solutions, new innovations are always developed for a work package. So you're always in the system. You can't get out of the system. You can pay people on site per work package. You can tender work per work package. You can standardize work per work package. You can scale data per work package, or you can automate flow per work package. Everything is in a nutshell. And that's how our body is. Cells are cells. Doesn't matter. They work all the same. We call them Stammzelle. I don't know what is in Danish, but this is let's say, a core cell. What you can create each kind of cell out of this. So they're normally like in the bones, yeah, and then you extract them for making cancer therapies. So that's a cell, and how you do organs, that's what you do in trains. So a system always works on that levels, and if you do not take these technology advance, you're always stuck in the end to being a kind of just a scrum. So I just want to show you one of the examples where we did a 1 hour TAKT time. These are the TAKT areas. They reduced 70% of time in that project. They did a project, renovation project for a supermarket. They did it in 3 days instead of 10 days. And normally there's always one work group on site. It's possible. It was a hard thing. It was very tiring. The 3 days was intensively, but they made it. I just want to show you it's nothing, let's say, theoretical. We do this also in practice. We test this, and we're trying to balance the things in the end. We are production engineers. So we are trying to create the full production and also control the production in the end and see the outcomes of the production. Good. So done with this. So I will just I will ask for questions shortly, and then I will start starting to give also insights into the software, why we do things in the software. So trains, wagons, work packages, sequences, all that good for you? Any kind of questions? Nothing? Claims? Something you have there?
There's a lot of interesting points, Janos. Maybe you should show the software, and then we can gather the questions together. I have some.
Good.
But
Good.
yeah,
perfect.
Take it, I think.
Perfect. Let me shortly see how I will check shortly. Good. Then I will share. There you are. Good. So why we do TAKTing? So the first thing is we don't want to be in the end software company there. It was never the aim for us to raise software. It was always the aim for creating production. And what we saw is always when Excel starts to be there, in the massivity and the data behind one work package is breaking the system in Excel. So we did that in, I think, 2012, 2013, 2014, where we see there is no possibility technology-wise to keep with this. And all other softwares try to be scheduling softwares. Scheduling is not the issue. It's like, yeah, of course, connecting bars in the end, that's one thing. But you can't control a production system with a scheduling tool. It's made for something different. And that is my biggest aim is we use always things from Gantt charts, what is developed from 1900. Mr. Gantt did that around 1900 for linear construction site, never aimed for making this complex 3-dimensional MEP works in the building. It's just the wrong technology for using it. So TAKT planning gives us the possibility to do things in a, let's say, complex, production-driven world But still there, when a lot of, let's say, systems say, yeah, we can do TAKT planning, then most of them are visualizing TAKT planning. They have the possibility of use the same kind of technology. This is like a, we call it a Ort-Zeit-Diagramm, so a diagram of place and time, as you say there. So like a box system. It's nothing what is invented for TAKT planning. It's just showing the TAKT planning, that's for sure. But what is behind is the full system, why you have trains. We are creating schedules in minutes by using standardized trains. They are already working for us, and we just copy them together. We scale them, we balance them, and we have a full system with work packages, work steps behind that. So in the end, what I don't want to do is I don't want to create TAKT schedules. These TAKT schedules are already done in the discussions. We are doing these things. I want to change, I want to optimize, I want to do these things then in afterwards. So this whole process from having the first schedule and then developing this more and more sharply to the construction needs, that's what we're doing. And even though we're on the construction side, we are changing the trains. Sure, of course, but we always do this in production laws. So let's go back here and to the system, and just to show you, this is a project. It's just my test project. About 4,000 active work packages here. That means around 4,000 lines in the normal Gantt chart. And even though I can see the flows directly, you can see the trades and the work packages underneath here. You can see if the wagons are a bit higher. Then you have a timeline above. We call it here the flex bar. So where you can see all the data of it, because I want to see all the data of my full production system in the end on the screen. And the first data here is the status. So the status shows me which of the work packages in which status. And I can filter for any kind of thing. I can filter for, let's say, for just the status of, let's say, the purple one. And all the other things are faded. So I can just check for that trade, or I can check for that trade and the green one, and the green one, and the yellow one. And I can just look for the yellow one, the green one, and the purple one. They are in started, or in started and done, or started, done, and ready. And that's used for all the other trains as well. So at first, I have a possibility of 4,000 work packages filtered by status, by colors, by their traits, also by pictograms. Each of the pictograms, you can see the pictograms are here highlighted, which are possible for that colors. So I can also go for their particular work, what I want to filter for. So I can filter for any kind of data drop here in there. I can also now go for the filter and saying, okay, give me not the status of it, give me the manpower for these trades. Give me the costs. You can have each of these. You can have the payout costs. You can have the budget. You can have the tendered. You can have the labor costs paid out. Yeah, material budgets. There's all these data is in the work package, and your filter is already for that. It's about getting precise any kind of data in there, what you want from each kind of perspective. You can also filter by each of the trains you have in there. The names of the trains are here, so I can rate or filter in just one train for that work packages. So any kind of possibility of filter data-wise is possible now directly in the schedule. That's a tremendous important thing for us because we are talking about that schedule every day. So that's what we're trying to do at first, to get the full picture in there. Good. So we have a lot of possibilities of filtering, but that should be not the major point. It's like you have different kind of trains and they look totally different. So each of the trains I can also unfold. So if I put them all together, I have a list in the end of a schedule that shows me exactly here, as you can see, that's my full schedule. And it shows me exactly how long I am. So I have a bar, but the bar shows me up to which point the train goes and then how many takt times longer he will last to get to the end. So I have a full schedule that has 20 lines, even though I have 4,000 work packages. Yes, I know this is nothing different than I have normally in a Gantt chart, but the possibilities here also in filtering and just opening one part means always you have one production unit in there. So I open one part and that's my production unit. So my production aim, and this is another one. So if I now start, and I will go shortly, right, a bit deeper, you see the detailing of all the things. There is each of the work package you have there, and you have the status of each of the work packages. So if I open the train here, it shows me all of the areas. If I click here, it shows me the work package with the content. And here is the full juice. Here is the full information drops. And we have work steps in there. And these are the work steps we can check. We have time management. So we can create a list of things of I did work for this day for that amount of workers, and I have for the next day, and for the next day I have full reporting system in that work package, and it's for all other 4,000 work packages as well. I can put pictures up. I can have 3D elements behind that. I have a log list that shows me all activities since the start of that work package. Everything what happens by each of the persons. I have the possibility to have a work package, let's say planned effort and a calculated manpower on the elements, for example, IFC elements. I have crane hours, what I put behind this. Everything is in the work package, and all work package work the same, all of them, everywhere. If you once get into the work package topics, you can create any kind of information in a work package everywhere. That's a standard, yeah. So now I have a question, Daniel.
Yeah, and I would like also to hear, Jonas, there's a lot of data and information. Can you say a little bit about who has access for this? Is it only one TAKT expert allowing to have access for all this information, or to change all some of these?
No, we have a. I can explain it in a minute. Yeah.
Yeah. And then okay, Daniel, please.
Daniel.
Thank you, Morten. It was actually the same question about the data on here, but also who is keeping track of registering the progress on this? So now you mentioned something about crane usage, for example, but it's the same for any of the other data in there. And so that is the one question. And also how do you deal with, because it's very nice and perfect, how do you deal with tracking the constraints or the delays in this? Because I think what I was thinking of, you mentioned shortly the difference between a Gantt chart and this, and it may look the same, but here you have a lot of nice filters. But what should you actually use it for in real life? All these nice filters, can you use it as a steering or navigating or managing tool, or how has it actually been used?
Okay. So data access, delays, and what was the last one really to make it in a short?
To steer, to use this as a steering tool.
Steer, yeah, control, stack, steer. Okay, yeah, good. That's fine. So let's go at first for data access. So there is a full roll and write system in there. We have a company. That means in the company you have all your registered people from that company, for example. There you have roles where you can, let's say, standardize, and everyone that is invited is selected by one role. So the role could be, you can select each of the work package if he can enter things there, or edit it, or move it, or delete it, even though in our roll and write system. That's a typical German obsession. So we have a roll and write system, and in that roll and write system, we have multiple roles to build. And these roles have around, I would say, 4,000 to 7,000 different kind of roles in there, what you can do. Each of these is adjustable. So you can select your roles standardized, and each of the trades get their own roles for that work packages. So in total, you have full access of the roll and write system. And even though you can't, it's that you don't show any kind of information for cost, for example. So if you want to have a trade and they don't have to see the costs, you can just hide these kind of roles from seeing something in there. So everything in that data, and that's the magic point about it. We are just solving in a work package all the roles problems and visuals, and everybody of the roles can see everything and can use or change everything if you want to give access to it. So if you want to do this, let's say multiple in every kind of scale, it's hard to do. But if you just solve this once in a work package, it's always the same. And then you just have to tell, in this work package, you can edit the things as a trait. So you're just able to set maybe the status done or closed, for example. And you can upload pictures and you can check the work steps, but you can't edit the work steps and you can't see the costs and you can't see our defect steps because they are ours. We don't want to share them as a company. So everything is possible in managing these data in there to have really a sufficient view for everyone else in a different kind of way.
And the same thing with do this on an app. Each subcontractor or blue collar, who what we call them, they will register this on an app.
Yes, they will. They will register as, for example, in a smartphone or in the laptop or in an iPad. Or they get invited, and then there is an invited user. So they're not owner of that project. So you have invited users, they have different rights, and you set the rights for that specific invited user. And they have just possible rights for different work packages or just in one train, for example. This is also possible. So the selections could be very clarified. And on the other side, if you as a company, let's say, want to use it outside of the system, the RP is it's let's say a three-way RP. That means with callback system, you can extract any kind of information out of that work packages into your RP and send it somewhere else, to your Power BI dashboards, your data warehouse, and to work with that data. That's the full aim of it. It's not the death end of data. It's a kind of hub for data connections, and we connected, for example, logistics systems in around 2 hours, and they run the full logistics about over these RP to another other software system. So is that data access answered for you? So you can extract the data if you like by API, but you can also visualize the data and also make the connectivity and the accessibility in that data by each kind of different user management and selections. If you want to create for each kind of user your own role, it's a nightmare because you have 7,000 possibilities, but you can do it. That's a typical German thing. The delays, what means delay? That's a really big topic, because if you do not delay the train, I don't have a delay. I have in the moment just friction in my production line. So, and I have to manage in the production line. If I have to change my production line, that causes the delay in the system. So there is a different kind of demand of delay. So first you stay in your train. Let's say you have a train, open that train, and you see there is some work started. And normally you would see that if you're in that week, these things should be done. And these things should be, let's say, ready, and this should be started. So you see all the white bubbles here. The bubbles show you the status of each of the work packages. So even and I can filter for it. I can say, show me open work package, and you just look for the work package they open here. You see it colored and you see they are still open. So to see just what is open, what is not in a stage, what I should have, it's easy to do. So then you have the possibility to move a work package just into the future. I would not do this if you have still running a production. If you replan, yes, do it. But a replanning, what we normally do is 4 weeks maximum. So all 4 weeks we are doing the replanning. This means we move the train or the content of the train, so that we move our S-curve or our, let's say, we move this back. In the other way, we keep the plan to see that we are deviating from this. And then you have to, of course, analyzing the work package and see which of them have a real problem and a delay. So we really go Gemba and see which of the work package. We have just a button here, and I can see the work package, they are open. Like they have a stop sign. You can see the stop sign here.
Yes, but how does this work when you are every 4 weeks you are replanning and then you're moving your trains
work packages?
Work packages. How do you then still ensure that you meet your deadline or you meet your time frame if you're moving everything?
Look, I see it. I can see it. Like this is the end of my train. And if this is overrunning a milestone, I have milestones, of course, in there. I have train milestones. They're, let's say, connected here inside, and they're moving. And I have project milestones. They are connected to the train milestones. And the train milestones, they give me a explicit date, and they have a relation to the project milestones. And if I move the train backwards, my train milestone is overrunning my project milestone. And then my project milestone is going into red. If my train milestone covers a work package that has a stop mode, the train milestone is getting red, and then the project milestone is going red because the train milestone is connected to the project milestone. It's a bit now very deep into that, but that's a connection system. It's there. But I want to keep my production as first as a, let's say, constant flow, and I will just touch it if I'm really out of that flow. So the first prediction is keep the production line online.
Mm-hmm.
That's the first thing, and that is what normal, and that's a really complex thing. But the thing is, if you control your production line, and even though you get some delays in there, I normally, and again, this has nothing to do with this is TAKT planning. This is something that's how I do it, and you can use the technology as you like, yeah. But anything what we are delaying here, if I put this work package, for example, let's say I go in edit mode and I put this work package into that into the next wagon because it's delayed, then my system asks me again, do you want to do this for that amount of work packages again also? Yeah. So and then I say no, because if not, we see if he's doing this, I say no, don't do this. I just want to move this work package here. Yeah. And I can show you in another example. It is a bit too heavy. Wait, I have another one. This one is easier. So if I go for edit mode and I take this work package and I want to move this here, the system, I don't know why. I think this is because I'm sharing, is not taking over. It normally moves the thing here. Can you see that?
Yeah.
Exactly. And this is then what happens. That is moved in that work package.
They switched over or they pushed?
Well, I switch it with the team.
Yeah.
Well, what we normally do is we are organizing this thing together in a team.
Yes, I know that, but I think my concern was if there should be a delay or constraint that makes something the next work activity not be able to start on time, or you not be able to meet.
That fair enough.
Is that then a buffer that is in there, or?
Yeah. Then I put a buffer wagon in there. I put a buffer wagon in. We create a buffer wagon, and everything is moving up from there on. This was okay, and from here on we are delayed 1 week. So the buffer wagon is in. Of course, if there is a delay here, there is no problem now to move that work package here, yeah, and to get it there.
Yeah, so time is running. We only have 1 more minute.
Oh, yeah, you're right. I want to show you one thing more. You're right. And This is about, this is about the 3D topic. And we connected all these work package with IFC models and shapes. So what you can see is we have all of the TAKT areas here connected, and I can now do the 4D simulation running through my areas. So my train is now running through the different areas, and I can click on that and I can check these things, and I can even do the status here. Check these things, I can give a comment. I can move on, and you can see already the boxes, they are open. I move the things are still open here because it's on demand, on premise. And if I want to add also the 3D model, I have also the 3D model in there, and the things are connected here. So the 3D model shows me exactly the elements I have to build in that particular TAKT time. Why? Because in the work package, there's all elements is connected. I have the data from the work package and the elements. I can calculate my manpower per work package directly. And that's about scalability. If you do this once in your work package and you solve that, you can scale it for the full production of the elements. So that means we are not doing this by each work package for ourselves. We do this by math and scaling the things. That's in the end, the thing is, if you control the work package and you control the scaling, if you can't scale a work package that is once 4 weeks long and once 3 days long. If they are always the same speed and the same values, you can scale the work packages as once. And that gives you the possibility of deep data in there. So this scalability of the work packages keeps your full production then into a data hub. So thank you for this. I think we don't have any more questions to go for, or
I think we have some questions, some
we can
very interesting perspectives to discuss as well. I think we have to stop here, Janus, for now, and then we'll have another hour or more.
We can do, of course, another hour for the questions.
Yeah, right now. Okay, maybe I think some have to leave, and maybe we can have maybe 5-10 minutes for the last question if you have the time.
But yes, I have the time. Yeah.
For the ones who have to leave now, thank you for joining us. And there's a lot of comments on the great presentation. Very interesting, Janus. But let's hang around for the one who has the possibility to do that. There was a question about, I think you maybe you answered. That was the how you can work with constraint management and activity readiness check, how that can be integrated into the system. I think you have some examples of that.
Yeah, exactly. Yeah. So there is, well, again, TAKT is the technology, and as you use it, you can do it by yourself. It's not that somebody tells you, then it's not TAKT. It's just, it doesn't make sense for making, for example, a critical path as you have normally in a Gantt chart for around 3,000 activities. It doesn't make sense. Why? Because there is so much differences in the areas, in the moves. If you split an area, if you have another train set in there, if you split a train into two, there is so much operations you can do, and you still do in a production system, that you can't sustain with a normal critical path. It's not a problem by making critical path through the trains. So that gives you a good picture, like the milestones topic, what I told you with the train milestones, that has a certain amount of, let's say, quality in the train, and then this is connected to a project milestone. For example, roof closed or water tightness. Yeah, that's project milestone. And to this water tightness, there is certain amount of final work package. They have to be consistent in there. For example, layers of roof, facade, first facade layer, and maybe windows, yeah, and doors. So these are 4 work packages, and they are in trains. So they 4 work package create train milestones, and they are connected to the tightness of the building then in the end. So you can, any kind of, let's say, critical path, what you need really for the quality in areas, you can do it You can build there, but it doesn't make sense to connect everything. And the aim is not, and that's my personal thing, you can do what you want, but it's not to have one person doing the scheduling all the time. You go by production line, and each production line has to have owners like the trades, the foremans, also the control guy of the production line. That's what you have. They group people together into teams to have, this is your facility, this is how you work together, and try to steer the train. And if you have problems, raise your arm, yeah, and we try to cope it then in the system. But just raise the arm if you really run out of your production line. Yeah, that's a different system approach, I guess. And I would guess that for let's say critical path method, I totally say it's a failure. It's nothing. It's not working. It's like putting on a Gantt chart. That's like a Bobby car. That's a German toddler's car.
What do you work with instead? Because I hear the same thing here in Denmark, but also we can understand that the owners, or they have to have something that some.
Yeah, sure. Well, I can show. Wait. Can show what kind of graphs they look like. One second.
You can understand that they have to have some.
Sure, of course.
We have
multiple. The data is there. So the question is just how you create that data and how you visualize that data.
Yeah, so maybe how you use it, because the critical path can be in one way when you start the project, but after 100 days, 200 days. It could have changed, or it would have changed for sure.
Well, yeah, of course. Wait, I have to go in present mode. Then I have to select the right one. Windows. For example, it looks this way. So we see exactly where our milestones are, and we see where our curve is. And we see where the milestone and these bars here, like these bars here, is showing me the amount of work package I did according to plan. In this case, it shows me here, this is a bit going down here. It's not so significant, but that shows me exactly, this is the amount of work packages, and that's my curve I planned for. This is my original plan curve, and these are my progress on the bars. So I can see each kind of milestones, and I can filter for each kind of milestone and train. And in the trades, in the early accesses, I can see per trades different kind of content. I can see their execution, and I can see stormwater. What is not in my early accesses is far behind. And special systems. But the data, what you use is there. It's so massive selective. And you can ask any kind of question to that system and create out of this the data. We are also creating, and we call them speed mountains, like mountains for the first draft plan, for the second, for the third, for the fourth. And you can see how the work shift into the back. And we can filter then by milestones or by trains or by trades and see each of that. And the point is, the major thing, what I want to give there, it's the data source is so big. You have to select the right information for the right answer. And it's not always the answer, how far we are behind. That's not the answer. Not from a customer, for let's say from automotive. We need how far you're behind for that early access area, for that kind of qualities, how far you are behind for that area, because we have to put our logistics in there. It's not just be done. That's an easy thing. But this is also done with a very clear framework. But it's so much more fragile, and the information, each customer needs different kind of things. Sometimes he needs just one flat per week. Sometimes he needs a bulk of flats per month. Sometimes he needs the full building. Then it's easy, but then it's getting also later. So the overlapping and all the things, these things, this is something you have to find out with data. It's not an easy way. I don't want to give you an easy shot. I want to give you the full universe of data there. That's what in the end we have to create. Yeah. Is this understandable? How we're using? It's not this 1 or 0 thing. And I want to be very precise with this. I want to have a question for all the guys doing Gantt charts. If you really track your things by week and you have an 8 weeks activity, how can you explain me that you are now done 33.7% of your bar? What is the content of that work? If my work package is done, my work package is done. This is a 0 or 1 discussion. If I'm 99% done, I'm not done. That means I'm open. My work is not done. My 1 is not there. I don't have a check on it. How can you explain me as a normal guy from site? All our data, what we are in the moment using, is personal perception, is personal prediction of the content of the work. None of them are really calculating it. None of them are really analyzing it. They don't have the time. That's the reality of it. Our data source in the moment for all this critical path with all the progress in there is done on one person being on site and saying, hey, intern, can you tell me how many pipes you found in the next room? That's the truth. And this data is not reliable. And the data on work package is reliable because it's 1 or 0. And they don't have to check for the amount of things they have. Are you done with drywall 1 in this room? Okay, you're done. I don't calculate or something. I just say done. So it makes also this kind of tracking on the construction side much more easy and, let's say, less defects related. Was that answer? Okay. I'm looking, we call it data analytics, TAKT analytics, data analytics, TAKT analytics. So we have now 40 billion data points in our projects. And this is running each year. So I found now different kind of ways to use that data, but I'm still not there. It's not finished. But the transparency we gain, it's brutal. It's so crazy what I can see in there, instead of having a critical path.
How are your expression or experience with using the TAKT planning in the construction sector industry globally? Do you see it in increasing these years, or?
I think it gets its momentum. It's not that it is like booming everywhere, but well, we need a kind of, let's say, pragmatic approach to give it to the people. That's also one of our aims. So don't make it too complicated. One thing is for simulation, for example, we have a simulation what we built for, and we give them full access and saying, you go for 10 minutes, you have to build that building with 8 to 12, 11 people. Yeah. So, and you go by yourself and you can use any kind of method and try it. Just go for you and don't explain us afterwards. Yeah, this was easy. They are failing mostly because not they have the wrong system or they have the wrong approach. They just not really in one system really understanding what everyone has to do. So everybody has a slight different way of doing things, and that makes in the end a total glitch. So the thing is, if you get everyone in a structure that everybody can understand and everybody can follow, you have the maximum peak in a system. So that's one of the things. So I see that we are getting in all of our projects a kind of momentum with TAKT planning, and we also do it by contracts. So it's a contract thing for us. It's a requirement thing. We want to have this, and we want to play with this also with the people, and do this together. And on the other side, of course, there have to be the willingness of the trades and also the GCs and also, yeah, the customers to work with this. It's a training way, but for us, like, yeah, I saw a lot of people when they once get to this, they don't want to go back because they have so much more efficiency on this.
Janus, we have to stop here.
Yeah.
It was
Okay.
it was very, very interesting, and I want to say thank you very much for a great presentation. Are we allowed to share your presentation with the participants after today?
If with the participant, no problem. And
Yeah.
don't just official,
No,
but just
no.
if you want to. Yeah,
Sure.
there's one thing with
Okay.
that. There's one question. Maybe I do not
Yeah,
understand
actually,
the wagon part. Yeah.
yeah,
Okay.
yeah. And are we allowed to reach out to you for any questions afterwards also?
Sure, of course. Again, for me, the important thing is it's not about, I don't want to sell anything for this. The thing is, this is my life. I'm working as a PhD. I'm working as a researcher. I'm working as an innovator, as a tool maker, as all these things together to drive that production thing. And everything what you came up with production and you get with a good idea, I'm happy to hear it. So that's for sure. The point is stop scheduling, start doing production. I think this is one we really have to go. There is no one person here in a plant or a production that is doing a Gantt chart or is doing any kind of scheduling. That's they don't do it. Yeah, they do production. Yeah, and that's the difference, I think, there.